All right, good morning. Thank you for joining us for the Preventive Controls Validation for Organic Food Processors webinar. We are pleased to have Dr. Erin DiCaprio from University of California, Davis with us again this morning, as well as Dr. Stephanie Smith from Washington State University and Jacob Guth from CCOF Certification Services. My name is Megan Donovan. I will be your host today. Behind the scenes, we have Larissa Hernandez providing technical assistance. She'll be the one fielding questions as they come in and may hop on as an alternative host if we have any technical issues, if they rise, hopefully not. And we're going to get to the webinar presentation shortly, but first I'm going to go through a few quick housekeeping items. And just to let you know, we're going to turn the videos off during the presentation, but we'll be back on during the question and answer session. We just wanted to let you know there are faces behind the voices. We're just not echoes on the internet. So as I mentioned, my name is Megan Donovan and I will be your host today. The CCOF Foundation is pleased to collaborate to host today's webinar with our partners. Guided by the wisdom of our farming roots, the CCOF Foundation unites the organic community to advance organic agriculture. We offer intentional education, financial support, and growth opportunities for organic professionals. We wanted to acknowledge that today's webinar is supported through a food safety outreach program grant from the USDA National Institute of Food and Agriculture. Please note the contents of the webinar do not necessarily represent the official views of the USDA. Also note this webinar is not providing legal advice. This is the 8th webinar in our 9-part Food Safety for Organic Food Processors series. If you missed any of the previous webinars, visit the CCOF website for links to the recordings. If you're having any difficulties connecting to the webinar, if you can't hear or can't see, please call our office for support at 831-423-2263. Press 0 for the operator and someone will help you connect to the webinar. And finally, a quick Zoom tutorial. I know many of us have spent a lot of time on Zoom lately, but just a quick review. To see the Zoom webinar controls, move your mouse over the image of the shared screen. If you're in full screen viewing mode and would prefer to view the webinar in a window, click on the View Options tab at the top of the shared screen and select Exit Full Screen Mode to exit full screen. Throughout the webinar, we will stop from time to time for questions and answers. To send in questions or to communicate with our webinar staff, click on the Q&A icon at the bottom of the shared screen. The question and answer box will pop open. Write your question or comments into the box at the bottom and click send. If you would like to send a question anonymously, check on the Send Anonymously box on the left. Note, we'll not be using the chat function for this webinar, so send all of your messages or questions via the question and answer box. And feel free to send in questions at any time. We'll collect those and use them during the question and answer breaks. At the end of a webinar, an invitation to take our webinar evaluation survey will pop up. To take the survey, click the link and answer a few quick questions to help us improve our offerings. As a final reminder, today's webinar is being recorded and will be posted on the CCOF YouTube channel. We'll send a link to the recording along with the PDF of the slides to all webinar registrants. And just to note, we have a nice crowd in the audience today, and we're going to try to get to as many questions and comments as possible. But if we can't get to your specific question, we just wanted to apologize in advance and encourage you to follow up with us after the webinar. So thanks again for attending. And with that, I'd like to introduce our lead trainer. Dr. Erin DiCaprio is an assistant specialist in cooperative extension at the Department of Food Science and Technology at the University of California, Davis. Her area of expertise is microbial food safety, with an emphasis on foodborne viruses. Joining Erin today, we have Dr. Stephanie Smith from Washington State University, as well as Jacob Guth from CCOF Certification Services Food Safety Program. And they'll be jumping in from time to time to answer questions related to their area of expertise. So with that, Erin, I will hand things over to you.
Thanks, Megan, and good morning, everyone. Thanks for joining us today. So the focus of today's webinar will be validation. If you haven't had the pleasure of doing a validation study in the past, we hope to provide you with a little background information on what validation actually is and give you some tools to go forth and jump in on a validation study if that isn't something you have experience with. We'll also talk about verification, which ties in to validation as well in today's webinar. So first, we'll kind of set the stage going through the definitions of validation and verification, talk about some of those tools that can be utilized for validation, and we'll end today's webinar with a really brief example of what a validation study might look like. So I wanted to set the stage at the beginning to kind of weave in where validation fits in this overarching preventive controls for human food rule. So the preventive controls for human food rule aims to have food processing facilities build a food safety system. And so this slide gives an overview of what is included in that food safety system. So good manufacturing practices, or GMPs, these are really the base level things that must be done to mitigate food safety risks, and they are really the foundation of this food safety system. So we had a previous webinar that focused on good manufacturing practices, so definitely check that out if you're not familiar with GMPs. So after those good manufacturing practices, the hazard analysis is the next important piece of the food safety system. So the hazard analysis is a systematic review of your process that highlights all the potential hazards associated with your product and process. And then as part of that hazard analysis, you need to determine whether or not those hazards that you've identified are reasonably and foreseeable to occur in your food product, and if they require a preventive control to be implemented to reduce the risk associated with that hazard. So there are 4 types of preventive controls that can be implemented. The first is the process preventive controls. So if you're familiar with HACCP systems, these are what are called critical control points under in your HACCP plan. And these are things that you would do in your process to control a hazard, like thermal processing or acidifying a product, etc. So our process preventive controls are the one type of preventive control for which validation is required. So you're going to hear me say that a lot throughout the day today. But there are 3 other types of preventive controls that may be implemented. Next would be your sanitation preventive controls. And these are preventive controls put in place for hazards that are associated with the environment that may cross-contaminate foods during production. There are also allergen preventive controls, and these primarily are related to ensuring proper allergen labeling on a product. If you have an allergenic ingredient in the product you're producing, these allergen preventive controls are put in place to make sure that the label that you're putting onto those products include the allergenic ingredient. Supply chain preventive controls are those that require supplier verification procedures for a particular hazard associated with an ingredient or a raw material that you're using, in which you're relying on the supplier of that ingredient to control the specific hazard. The hazard analysis, the preventive controls, and all other documentation related to implementation of the food safety plan, including validation, monitoring, verification, and corrective actions of the preventive controls, make up the entirety of the food safety plan. One final piece that is frequently required is a recall plan. So a written recall plan must be included in the food safety plan if at least one hazard has been identified that requires preventive control. So a food safety plan, this robust document, is required for food processors that are fully covered by the preventive controls for human food rule. So the main sections of the food safety plan are listed here. So the hazard analysis, this is really the critical first step in developing an effective food safety plan. After that hazard analysis, if there is at least one hazard requiring a preventive control, those preventive controls need to be defined within the food safety plan. So what exactly you're going to be doing as part of that preventive control. And as I already mentioned, if you do have one hazard that requires a preventive control, then that written recall plan is also required. So the remaining sections of the food safety plan is really everything that's needed to implement the plan. So this includes validation studies for any process preventive controls that are going to be implemented. It also includes the records related to monitoring all preventive controls, as well as verification activities related to monitoring preventive controls. So we'll talk in depth about what kind of information needs to be included as part of those validation studies that, again, are required for your process preventive controls, and then what kind of activities are included in verification. So verification, you're going to be doing that for all 4 types of preventive controls. So we're focusing today on validation and associated verification activities related to process preventive controls, as well as verification activities that are going to apply to your sanitation, allergen, and supply chain preventive controls. So validation is the scientific evidence supporting the implemented process preventive control aimed to minimize the risk associated with the identified hazard. Verification, on the other hand, are the procedures that you put in place to ensure that your preventive controls are being implemented as intended. So we're going to go through these definitions again as we work through the webinar today. So I wanted to start with a quick poll and kind of gauge the level of experience with validation within the group. So do you have experience with validation of a process preventive control? And so our options here, I have validated a process preventive control myself, or I've worked with a consultant on a validation study for a process preventive control. I've assisted with validation of a process preventive control. I don't have previous experience with validation, or I'm not sure. So I'm going to go ahead and just close this poll out. We'll share the results. So it looks like we have a number of folks that have validated a process preventive control themselves. Kudos to you. A few folks that have either worked with a consultant or someone else within their business on validation, but also a good number of folks with no previous experience with validation. So today, this webinar is kind of geared to those folks that don't have any previous experience with validation, but good to know that we have some folks in the group that have experience with this process. So here's the definition of validation as written in the Preventive Controls for Human Food Rule. But validation is essentially gathering technical evidence, meaning data, that shows that the process preventive control established will effectively control the identified hazard when implemented properly. So in other words, are we doing the right thing to control the hazard that we've identified? The validation establishes the scientific basis for process preventive control in the food safety plan. Again, you do not have to validate sanitation, allergen, or supply chain preventive controls. So the scientific basis for the process preventive control can be scientific principles or data. It may also include expert opinions. Oftentimes, it includes in-plant observations or experiments like doing your own in-house challenge studies or doing some thermal modeling within your equipment. It's important to note here that the validation of the process preventive control must be overseen by the Preventive Controls Qualified Individual, or PCQI. So ideally, this would be someone that works for your company that is this Preventive Controls Qualified Individual. However, it is also possible that you work with someone externally that is a PCQI, but they would need to oversee the validation and also have a hand in some of the verification activities related to implementation of preventive controls. So when do we need to do the validation? Ideally, validation of the process preventive control will occur before you start production. If not, it is written in the regulation that validation of the process preventive control must occur within the first 90 days of production. Validation also needs to be conducted again when there is a change in the process or your ingredients, a significant change that could impact the effectiveness of that process preventive control. You need to go back and revalidate that process preventive control. You may also, through kind of deviations from that process preventive control you've established, realize, you know, the original validation was not effective, so you would want to go back and revalidate that process preventive control if you're having issues, you know, meeting those critical limits. Again, you do not need to validate allergen preventive controls, sanitation preventive controls, supply chain preventive controls, or your recall plan. However, it may be useful to validate some of these types of preventive controls. For example, for sanitation preventive controls, if you have a risk of allergen cross-contact in your facility, meaning, you know, you have one production line where you're running a product that has unique allergens. So you need to clean and sanitize after running that allergenic product to make sure you don't have allergen cross contact with a non-allergen containing product. It may be valuable to do some type of in-house validation study if you're using, you know, some complex equipment that's difficult to clean and sanitize, that in fact that cleaning and sanitation process removes the allergenic ingredient from that equipment. This might also come into play for organic processors that are running conventional and organic products on the same equipment. So some type of validation or study or proof essentially needs to be shown that the cleaning, sanitation, or purging process that occurs is actually mitigating the risk of commingling between your conventional and organic products. So validation essentially includes that initial validation. So pre-production or 90 days post-production, that initial validation. It also includes a continual reassessment of that initial validation. So, monitoring trends to ensure that that validated process is working as intended. And then revalidation when required. Again, when you have a significant change to your process or your ingredients, or you're observing frequent deviations from that validated process, you would want to go back and actually revalidate that process preventive control. So I'll talk more about when you would want to revalidate in a few minutes, but I wanted to first speak about the initial validation and a key concept related to that, to validation as a whole, called a critical limit. So the critical limit, again, if you're familiar with the HACCP system, you've probably heard critical limits before, but this is the value or the parameters necessary to control the hazard that was identified. So if that critical limit is not met for any reason, there's a potential risk to human health. Failing to meet the critical limit results in a deviation from what we call our scheduled process, so that established process to control the hazard. So if we deviate from that critical limit, that deviation needs to be documented, and a corrective action to rework or dispose of the impacted food product, as well as a root cause analysis to determine what caused the deviation, what was done to fix the issues that caused the deviation. All of that information needs to be documented as part of that corrective action. So what happened to the product, what caused the deviation, and what did you do to fix that deviation? That's all part of the corrective action that needs to be documented. There's also what's called an operational limit. So this is a value or parameter that's set by a processor that is typically more stringent than the critical limit. So this operational limit allows for essentially a buffer zone in which failure to meet that operational limit allows for a process adjustment before you deviate from that critical limit. So these process adjustments can be made with less or even no documentation, which saves a lot of time during production. So most operational limits, those are going to be set internally by the processor. They may have some quality implications as well, but they do kind of give this safety buffer zone where you can go make process adjustments before you have a deviation from that critical limit. So to try and kind of make this a little more clear, here's an example of a critical and operating limit for a thermal process. So the x-axis here on this chart is time, and the y-axis is the temperature measured in degrees Fahrenheit. So in this example, the critical limit shown here is 160 degrees Fahrenheit, and the established operational limit is 180 degrees Fahrenheit. And this dark red line is the measured temperature of the process over time. So you can see there are 2 points here and here where the process falls out of that operational limit. So it's below the operating limit. However, it's still above the critical limit at these 2 points. So in this case, there's a process adjustment made, and you can see after this first dip below the operating limit, process adjustment, we go back above the operating limit. And again, we make another process adjustment after this second drop below the operating limit, and we go back above the operating limit. However, we then have another drop in our processing temperature, and in this case, we drop below the critical limit. So when we go below that critical limit, this is a process deviation. So in this case, you need documentation of that deviation and the corrective action. So for each process preventive control you establish, you're going to outline the appropriate corrective action. So what you're going to do if a deviation occurs for the set critical limit. So all of that is going to be defined when you establish the process preventive control. So the initial validation includes confirming that all the potential hazards were considered during the hazard analysis. So, going back, reviewing that hazard analysis, making sure that you identified all the hazards of concern and implemented preventive controls when required for those hazards. And that initial validation is also going to be where you develop the critical limits and confirm that the critical limits are adequate for the hazard based on scientific evidence. So for your validation, you can rely on existing data and guidance documents. The FDA has some hazard guides that are really useful. Specifically, I'll show one of those when we get to the example that we're going to go through at the end of the webinar today. Another really useful document from FDA is the FDA Food Code and its annexes. They're often time, temperature, acidification parameters for different foods in the food code that you can also reference. There may also be useful information from trade organizations. So I'll show an example today from the American Institute of Baking as we go through the example at the end. So there are trade organizations and other industry resources out there as well that you can utilize for your validation. There are also validated microbial modeling programs that can be utilized to determine how a specific microorganism will survive in a specific food under different processing conditions. The USDA's pathogen modeling program is one of the most commonly utilized, and you'll have a link to some of these modeling programs provided in the resource list today. You can also look at peer-reviewed scientific literature. There are many faculty and food science departments that work on validation studies for different foods, and you can, in some cases, use some of those scientific studies as part of your validation. You can certainly also reach out to us at University Extension. So there are actually many universities across the US that have dedicated faculty within their food science departments that function as a process authority that can give you specific guidance on your validation study and are actually going to sign off on your process letter. So for those of you that might be in Washington, Washington State does function as a process authority. In California, we at UC Davis don't have that same function, but we do consult frequently with processors and helping them find appropriate data to use in their validation studies. I'll also say that if you don't have previous experience with validation, that engaging with a consultant can also be really, really helpful for your validation. I would, ensure that your consultant is very familiar with the process you're actually utilizing. You want to have very open communication with them, ideally have them in your facility during production so they can really make sure that the validation work that they're doing accurately reflects your product and process. So as you implement the food safety plan, another part of the initial validation is to note if there are any issues with the validated process and make adjustments as necessary. Things don't always work the way that you intended. So just making sure that you are able to meet that critical limits in your facility. It's also really important that the operators responsible for monitoring the process that have critical limits understand the importance of monitoring that process, of record keeping, that they are well versed on the difference between the critical limits and the operating limits, and that they're also familiar that if there is a deviation from that critical limit, what corrective actions are required if that deviation occurs. So revalidation is the process of making sure that the process preventive controls is still valid and that you are still controlling for all relevant hazards in your product. So you need to do this at a minimum of every 3 years. So this is written in the preventive controls for human food rule. So you need to go back, reanalyze your food safety plan, including revalidation, a minimum, again, of every 3 years. You also need to conduct revalidation when your process or product changes, if you have a significant change in a raw material, for example. You would also need to revalidate if you have continuously reoccurring deviations. So if you're failing to meet that critical limit time after time, you need to go back and revalidate. You would also want to revalidate if new information or hazards have been identified for your product. So if there has been an outbreak or recalls associated with a product like yours, you want to go back and revalidate to make sure that the critical limit you've set is still adequately controlling hazards in your product. Or maybe there's a new hazard that you didn't consider in your initial hazard analysis identified through an outbreak or recall, then you would also have to go back and revalidate as well. So there's another number of other issues that may initiate revalidation, but I think the important take home here is that it's not a one and done situation with validation. Your food safety plan is a living document that does, per the regulation, need to be revised, reviewed a minimum of every 3 years, but it's also important to be proactive and make changes before that 3-year limit if you've noted any of these things, such as changes to ingredients or processes, any outbreaks or recalls in associated or like products to yours. You want to go ahead and revalidate before that 3-year limit is up. So we're going to pause here for some questions.
Great, thanks, Erin. So I think if everybody wants to write in questions, go ahead while we're waiting for folks to type in. You touched on it a little bit during your presentation, but do you have any good tips for folks who are starting to work with consultants, like questions to ask them when they're first calling them, or other ways to get started, or just make sure you're getting the right person?
Yeah, so I think there are certainly some great consultants out there. I think you know, starting out, you want to provide them with as much information as you can about your product and your particular process. I would, you know, be leery of someone that wasn't asking you a lot of questions about your product and process. I would also encourage you to invite these consultants out to your facility so they can get a better grasp of what you're doing. Some may be hesitant to do that, but if I am paying someone to help me with validation, I think it's completely reasonable to expect them to travel to my facility and actually see what we're doing. I think it's always best to have someone on your team as well, regardless if you're working with a consultant or not, that has a hand in that validation, in developing the food safety plan, because when an inspector comes into your facility, you're going to have to, in some cases, defend the decisions that were made. So having someone in-house that has that experience is really beneficial when you do have an inspector coming in, somebody that understands the data, the scientific basis, the entirety of that validation study, and can talk through that with an inspector as needed.
Great, thank you. We had a couple questions come in, and one of them was wondering, why do we not need to validate food allergen, sanitation, and supply chain, and other preventive controls?
Yeah, so I think per the regulation, you don't have to do it. I think there are certainly instances where you would want to validate some of those other types of preventive controls, but essentially why it wasn't included in the regulation is that it can be very difficult to validate those other types of preventive controls. So, sanitation, for example, if there's a risk of allergen cross contact, it can be the testing procedures for allergens aren't typically something that are done in-house. There may not be commercial labs available to do allergen testing. So I think that was kind of considered as the regulation was written, that these other types of preventive controls are more challenging to validate. Comparing preventive controls to HACCP regulations. So if you look at preventive controls for human food versus HACCP, both essentially have process preventive controls. So people that had implemented the HACCP system, they're familiar with validating those process preventive controls, but HACCP doesn't include the other three types of preventive controls. So allergen, sanitation, and supply chain, they're not formally written into the HACCP regulation. So I think that was another piece of it as well, that folks in the industry are well-versed at validating, critical control points, and so that also feeds in to the process preventive controls. I will say for sanitation as well, if you've identified an environmental pathogen as a hazard that needs a sanitation control in your facility, there is a requirement that you do environmental monitoring in your facility. So going through and swabbing, equipment, maybe drains, other locations in the facility, and do routine testing to try and find these environmental pathogens if they are in your facility. But that's kind of aside from the validation piece. I would say most people, they do some level of, won't call it a validation study, but there is some level of scientific data, right, supporting the implementation of these other preventive controls. It's just, per the regulatory language, not required.
Great, thank you. Yeah, it's interesting how the different regulations sort of, morphed into each other and how that impacts what's required and what's not.
Mm-hmm.
So we have one quick clarifying question, and then I think we'll move on. Someone was wondering, for the initial validation slide, it listed 3 items, and they just wanted to confirm because they didn't get one. So what they saw was confirm all potential hazards, confirm critical limits, and they're just wondering what the last one was. And also note, we'll be sending out these slides in the recording, so you'll have access to all of that after the webinar.
Do I remember what the third one is? So it's ensuring all of the hazards were identified, setting those critical limits, and then I believe it was just making sure that you can meet those critical limits in your facility. So sometimes, we have it down on paper. This is our critical limit that we're going to meet. But, during production, maybe you can't reach that target time and temperature for some reason or another. So you set the critical limits, but then you have to make sure that you can actually achieve those in your facility. So that might, initiate going back to the drawing board in some cases.
Thank you. So I think we'll keep moving, but again, if you have additional questions, feel free to write those in as we go.
All right, so now we'll get into verification. So here's the definition of verification from the Preventive Controls for Human Food Rule. But essentially, these are the processes or the procedures you put in place to ensure that the preventive controls established are being properly implemented. So in other words, are you doing what you said you would do? Are you actually implementing those preventive controls? And, we always say if you didn't write it down, it didn't happen. And so record keeping is a really big part of verification as well as review of those records. So verification activities include those to support preventive control is being implemented properly. It also includes, monitoring and record keeping practices related to the preventive control. And verification applies to all your preventive controls. So it applies to the process preventive controls, the sanitation preventive controls, the allergen preventive controls, and the supply chain preventive controls. So one of the most basic verification procedures that you're going to do is records review. So you're going to generate a lot of records related to each of your preventive controls, and it is required that those records generated are reviewed in a timely fashion. So again, you're going to do records review for all 4 types of preventive controls. There are also some types of verification procedures that are a bit unique to each one of the preventive controls. So I want to go through some examples of those here. So for a process preventive control, one verification procedure that you would undertake is calibration of equipment or tools used for monitoring that process preventive control. So things like calibrating a pH meter or your metal detector, for example. You would also potentially have a verification procedure of your process preventive control that would include some level of targeted sampling and testing of your product. For your sanitation preventive controls, verification procedures would include inspection of your equipment to ensure that it's been adequately cleaned and sanitized, to minimize microbial cross contamination or allergen cross contact. You may also, if you have those environmental microbial pathogens identified as a hazard, you're going to be doing some environmental monitoring, some environmental testing for those environmental pathogens. So in many cases, folks don't directly test for the pathogen. They'll use some indicator organisms to get a sense of, is this environment conducive to the growth of these environmental pathogens? Some folks may also use ATP swabs that give you an idea of the organic load that's left on a surface after cleaning and sanitizing. So some folks might use that to verify cleaning and sanitation related to either allergen cross contact or environmental pathogens. For your allergen preventive controls, this would include, label review of the labels coming into your facilities, ensuring that the label contains the allergen that's in the food product. It might also include, that visual inspection, again, making sure that equipment has been adequately cleaned and sanitized to minimize allergen cross contact. And then for any supply chain preventive control, a verification procedure would be audits of the supplier. So a second party audit would be you going to the supplier and doing your own audit. And then third party audits, that would be, working with an external entity, which would go into that supplier and conduct an audit and provide you with the results. You also may be doing targeted sampling and testing as part of the verification procedures for your supply chain preventive control. So actually testing some of the ingredients for a particular hazard of concern to make sure, again, verify that those ingredients are meeting the standards that you've set and those hazards are being controlled adequately. So the verification procedures demonstrate that the food safety plan is being implemented, and the type of verification required is going to vary based on the product, the process, and facility. So verification would include the calibration of any instrument or equipment used to measure or monitor a process preventive control. It may also include some targeted testing. So again, that could be raw ingredient testing to ensure that your supplier is adequately implementing preventive controls. It might be testing your own product, so final product testing, for example, to ensure that your process preventive control is working as intended. And it can also include environmental testing or monitoring if you've identified environmental pathogens that are as a hazard. So calibrating your equipment you're using for monitoring your process preventive controls ensures that the data that you're generating is correct. So the types of equipment that require calibration would include thermometers, pH meters, metal detectors, etc. And the frequency of the calibration, it depends on the instrument. So there are what are called routine accuracy checks that are often conducted in-house and occur on a frequent basis, so daily, weekly. So for an example, a thermometer, an in-house accuracy check would typically happen on a weekly or monthly basis. And then it is sent for an external calibration against a standardized thermometer once a year. So in-house, you're doing those routine accuracy checks. And then once a year, you're sending that thermometer out for calibration. A pH meter that's used to monitor the acidification process of an acidified food. You're going to do that calibration in-house. So you're going to have, your standardized pH buffers that you're calibrating with. And that calibration needs to be done every day before you start production, and then every hour during production. So different types of equipment that you're using for verification, they're going to have different frequencies at which they're calibrated, or you have an accuracy check, and that frequency is often, going to be dictated as well by the product that you're working with. The records generated for calibration and accuracy checks must document the results of those accuracy checks and calibration procedures. They should also provide traceability to the reference device, and the records for calibration must be reviewed, or that review must be overseen by a preventive controls qualified individual. So you can see this preventive controls qualified individual has a lot of responsibility. So, this review of verification records being one of them. So there is value in having one of these preventive controls qualified individuals in your own business, because you can imagine if you're working with someone externally, it can be potentially challenging to have them come in and oversee the records review. The verification can also include chemical or microbiological testing of ingredients, in-process materials, or finished products. So if there is product testing, the testing procedures must be validated testing methods. So validated methodology, there are many different types of validated methods. Most commercial labs are using these validated methods, but you would want to make sure if you're setting up a contract with a new lab that they are using some of these methodologies. The records in the food safety plan need to include the testing, so what you're actually testing for, so the microorganisms or the analytes, the relationship of those test results to different lots of your product, the number of samples that you're going to be collecting, how often you're going to be collecting, the analytical unit. So each method has a different unit the results are reported in. So you need to include whatever that unit is. If it's colony forming unit per 100 grams, that needs to be included in your records. You also need to, within your records, list the analytical method, that validated method that was used to run the test. of course, include the lab, name of the lab running the test. And then you would also have to define, what the action level would be for your test results, and define what corrective action you would engage in if that test result is outside of your acceptable level. And so depending what tests you're running, what food type you have, you may have very different, kind of these action levels for a particular test, but you need to define that ahead of time. Just getting all these test results, all this data without kind of establishing what that limit is and what you're going to do if you're above that limit is kind of a waste of time and money. And an inspector is going to be looking for that. If you have these test results, what's your action level and what do you do if you don't meet that criteria? So environmental monitoring is another type of testing that's required for a ready-to-eat food or RTE food that's exposed to the environment after processing and before packaging, and that is at risk for recontamination with environmental pathogens, including Listeria monocytogenes and Salmonella. So in these types of foods, these ready-to-eat foods that are at risk for recontamination with environmental pathogens, the processor must routinely test the environment for the pathogens themselves or indicators for these pathogens. So again, just like other types of product testing, the types of records that are required are, the analytical method that's being utilized, the targeted test organisms. You also, for environmental monitoring, need to include the location and the sites of sampling, the timing and the frequency of that sampling, the laboratory you utilize to do the testing, and also define the corrective actions to be implemented if you have a test result that, again, is outside of those limits that you've set. So within your food processing facility, for environmental monitoring, really important that you establish zones. So a zone 1 surface would be a food contact surface. Zone 2 are surfaces directly adjacent to food contact surfaces. Zone 3 would be things like drains, other areas that could potentially impact zone 2 or zone 1. And then zone 4 are typically areas outside of the main production space. So many times environmental monitoring focuses on zone 1, 2, and 3. I will just say that if you are doing direct pathogen testing, so if you're looking for pathogenic Listeria monocytogenes or Salmonella, and you have a positive sample on a zone 1 surface, those food contact surfaces, that is essentially going to result in a recall of product. And if you have a positive for one of those pathogens in zone 2 or 3, then you may decide to recall product, but you would certainly want to implement a corrective action that is enhanced cleaning and sanitation in those areas. We've seen a number of outbreaks where results from environmental monitoring, there was not a adequate corrective action, and lack of that corrective action resulted in outbreaks. So you certainly, if you are doing this direct pathogen testing as part of your environmental monitoring plan, just be aware that, if there is pathogen in your processing plant, you're going to have to do some things to remove those pathogens. Another important verification procedure that you're going to be doing for all of your preventive controls is the review of records. So this includes review of the monitoring records and any corrective action records. And it's written in the preventive controls for human food rule that review of those monitoring and corrective action records needs to be done within 7 days of that record being generated. Again, the records review needs to be performed or overseen by the preventive controls qualified individual. So you can see how it can get tricky if you don't have someone that works in your business who is the preventive controls individual to get those records reviewed within that 7-day window. And the idea, with that shortened window for the records review, that if something went wrong, that potentially means that a hazard wasn't controlled, that if those records are reviewed within 7 days, you're able to pull that product back out of commerce quickly, or maybe that product hasn't even been distributed yet, and you're able to do some kind of rework or destruction of that product before anyone's health would be put at risk. For other types of verification records, like your calibration, your product testing, your environmental monitoring, records related to your supply chain preventive control, these don't necessarily have to be reviewed within that 7 days, but within a reasonable time. So you do have a little bit of wiggle room with the review timing for those other kinds of verification records. But I would always say better to do it within that short window from production, because, if you wait a month and then you notice, oh, our thermometer calibration, we were completely out of whack, and now we potentially missed our critical limit on 10 lots of product that's now out in commerce, that's a much bigger headache to deal with and recall than if you're able to, catch those issues before product goes out into commerce. So this food safety plan, this is a dynamic document, and it is going to change over time. So the food safety plan as a whole needs to be reanalyzed a minimum of 3 years. So again, revalidating, looking back at the hazard analysis, you have to do that at least every 3 years. It would also need to be reanalyzed anytime a process or product changes significantly. And it would also change, of course, if there's unanticipated problems or new information related to potential hazards in the food. So you do need to keep kind of an ear to the ground when it comes to what other folks are doing, what's going on related to products related to yours, and are there any new hazards that have come up since you did that, you initially developed the food safety plan or did your validation. So significant changes may include changes in the raw material or suppliers. So something I think also very relevant to organic processors is, making sure that if you make changes to your suppliers or any of those raw materials, that those are still meeting the organic standards or your internal specifications related to food safety. Really, really important. There have been instances with outbreaks related to just something that seems as simple as changing a supplier. Anytime that you had recurring deviations to any of your preventive controls, that would also trigger reanalysis. Again, any outbreaks or recalls in similar products, or even in some cases your raw materials, would necessitate a change in the food safety plan. Another thing that I think maybe is underappreciated is changes in consumer handling practices that may warrant a review. So we may think a consumer is going to cook a product, for example, before consumption, but we may find out that that actually isn't occurring. So you may remember a few years ago, there were several outbreaks and recalls associated with Listeria monocytogenes in frozen vegetables. And so, there was kind of this overarching assumption that the consumers were going to be cooking these frozen vegetables prior to consumption. However, due to the outbreak and people actually were hospitalized, if some people passed away, it was clear that either the consumers were not adequately cooking prior to consumption, or there was some more novel handling practice that was leading to cross-contamination that was occurring. So this particular outbreak prompted the entire frozen vegetable industry to change their food safety plan. So, you can't always assume a consumer is going to do one thing with your food product, because as we know, people are very creative and they may be, utilizing your product in a way that you hadn't imagined. So making those changes to a food safety plan as those consumer behaviors change is also really important. So the reanalysis of the food safety plan as a whole should verify that the food safety plan, including the hazard analysis, is still accurate. You should also take the time to go back and review your records holistically to identify any trends that may be occurring in your process. And this is also a great way to ensure that the food safety plan is being followed. So, taking a step back and looking at all the records generated over, a significant period of time to see if you can pick out any trends is really, really important. And one of the benefits of keeping good records, because you can look back and see what's working well, what isn't working well. So, there are benefits beyond being compliant with regulations and keeping good records. So I'll pause here for some questions before we get into this last piece of the webinar, which is the example of what you might collect as part of a validation study.
Great, thank you. So we did have a question come in. Someone was wondering or commented that they thought the FDA guidance doesn't require Zone 1 monitoring, and we're curious if this had changed.
Yeah, it's not required. And I would say some folks shy away from doing environmental monitoring on Zone 1 because of the potential implications of getting a positive sample off a Zone 1 surface. I try and encourage people, don't be afraid of testing Zone 1. I personally, if I have an environmental pathogen on Zone 1 surfaces, I want to know about it. But yeah, it's not a requirement, but you would certainly, as part of initially setting up that environmental monitoring plan, you would be mapping out all of these different zones in your facility and determining which you're going to be sampling and the frequency of that sampling as well.
Great, thank you. So I think we'll keep moving, but we'll have the final question and answer session at the end for any additional questions.
All right, so I wanted to go through one quick example of how you might approach validation using the example of a chocolate chip cookie, which we discussed previously during the hazard analysis webinar. So here I just want to focus in on the process preventive control of baking the cookie. So just a refresh of the hazards associated with these cookies. So I'm showing the FDA hazard guide in the next 3 slides. If you haven't looked at this document and you're kind of stumped as to what hazards would be associated with my product, this is a really great resource to look at. It lists biological, chemical, and process related hazards as well as physical. So this is the table for biological hazards associated with cookies. And you can see on this guide, they flagged pathogenic E. coli and Salmonella, as well as Staphylococcus aureus. So the pathogenic E. coli and Salmonella, these are associated with ingredients used to make the dough. And therefore, the baking step is the process preventive control for these 2 pathogens. Staphylococcus aureus is associated with humans, and it often contaminates foods that are packed by hand after a kill step. So we have seen periodic outbreaks associated with baked goods and Staph aureus, and these baked goods packaged by hand. I would say, in this case, implementation of your personal hygiene practices and staff training through your good manufacturing practices would minimize the Staphylococcus aureus risk. So really important, again, that those good manufacturing practices are implemented because, they do a great job of mitigating some of these hazards. For chemical hazards in cookies, mycotoxin or natural toxins are identified. So these would be coming in on your raw ingredients. And so in this case, a supply chain preventive control or your good manufacturing practices would minimize these chemical hazards. And then for the processing of cookies, there are also many hazards flagged here. And one that's flagged is bacterial pathogen survival of a lethal treatment. So this is why we implement the process preventive control for baking, closely monitoring that time and temperature, because, that certainly is with any kind of raw dough where you have eggs and flour, we're concerned about those bacterial pathogens potentially being present. And so that baking step really critical for the safety of the product. So here's the flow diagram for the chocolate chip cookie. We're going to focus on the baking preventive control, but I just wanted to point out that there would be additional preventive controls warranted with this process. So another process preventive control would be metal detection because we have a mixing step here. There would also be allergen preventive controls because we have allergenic ingredients, which means we have to verify that the allergens are included on our label. If we're making other cookies with unique allergens in the same facility on the same equipment, like if we're adding walnuts to the cookie, then we would also need a sanitation preventive control to minimize allergen cross contact. Anytime there's exposure of the food to the environment after a kill step, there might be that risk of recontamination with environmental pathogens. And in particular for the baked goods that are being packaged by hand, we're concerned about Staphylococcus aureus recontamination as well. But let's look at some data that would support the selected time and temperature used for baking as a process preventive control of cookies. So one source of data you may be able to lean on are scientific studies. So this particular study looked at the survival of Salmonella during the baking of cookies. So to start, the first thing they did was study the thermal profile of dough. So the heating of that dough when it was placed in an oven at 350 degrees Fahrenheit. So in this chart on the left, The line on the top is the line of the oven temperature measured over time, so right around that 350 degrees Fahrenheit mark. The lines below are the temperature internally, well, I guess different parts of that cookie dough ball over time being placed in that same oven. So you can see and how they do this. I'll show you a picture in the next slide. They use a thermocouple, which is basically a little wire thermometer that's connected to a data logger that allows you to measure the temperature of different parts of that cookie dough during time, over time. So this is, really important to do because you rely on the temperature to inactivate the pathogen, of course. So you want to know how hot the coldest part of that food is going to be during cooking. So you can see for these dough balls, of course, the temperature of the dough is low, around room temperature, and then it slowly increases over time to achieve a temperature at the end of approximately 225 degrees Fahrenheit after 15 minutes in that 350-degree oven. So that gives you a sense of, the heating profile of that dough. The cookie itself is never going to get up to the same temperature of the oven. So in the same study, they inoculated that cookie dough with salmonella and then cooked it at 350 degrees for different lengths of time. And so this table over on the right shows at different times, so time is listed here, how many of their samples were positive for salmonella. So you can see at 10, at 11, at 12 minutes, they were able to recover salmonella from all of those cookies. As the time increased to 13 and 14, a few of the cookies still had salmonella that was able to be recovered, but at a cooking time of 15 minutes in that 350-degree oven, there was no salmonella detected. So based on this work, for these particular peanut butter cookies, we would need to, this is a study in a particular oven with a particular size dough ball, but here the process would be 15 minutes at 350 degrees Fahrenheit. So you can, go to literature like this to, set the basis for the time temperature that you're going to utilize. You might not find the exact product you're making in the literature, but there may be a product similar to yours that you can use as the scientific basis for the process preventive control you've established. For baked goods in particular, there are some baking process kill step calculators that can be used to estimate the required time and temperature to inactivate salmonella in various types of baked goods. So these models or calculators can be really useful tools for validation. So in the bottom picture, these are the thermocouples, these little wires that are being fed into the cookie dough balls. And then this is the data logger, which enables you to, again, monitor the internal temperature of those dough balls over time. This type of information, so actually, utilizing your equipment, your oven, doing this type of in-house study is a very important piece of validation. So, I think for some manufacturers of cookies, maybe this is above and beyond what they would normally do as part of their validation. But if you have, a unique product, really important to do your own internal studies as part of that validation to ensure that you are going to hit those critical limits. So this, might be an example where you're going to the literature, you've defined a specific time temperature you need to achieve within the cookie, but then when you do your in-house studies with the, temperature monitoring in the cookie dough, you're not able to achieve that same time and temperature in your oven for one reason or another. So doing this kind of study in-house can be time consuming, but really, really important data to gather to show that the process that you're able to meet that critical limit in your facility using your equipment. So verification procedures related to the baking process would include monitoring that oven time and temperature. So every batch, every lot of cookies you're making, you're going to be monitoring the time and temperature. It would include those accuracy checks and the calibration of the thermometer used to measure temperature, and then review of those records related to baking. If there is a deviation that occurs, there needs to be documentation of the corrective action and the root cause analysis to find out, what caused that deviation. And if, you find that these deviations repeatedly occur, this would be a situation where you would need to go back and potentially revalidate that process preventive control. So I think that brings me to the end. I'm sure there are questions, so let's open it up to the group.
Great, thank you. So one question that came in sort of in relation to our consultant discussion, and we've been talking a lot about, the Preventative Controls Rule and the Food Safety Modernization Act. And they were kind of curious in working with the external consultant, how, if you're also getting a third-party food safety certification, sort of what guidance a third-party food safety certification can provide you in developing and implementing your food safety plan.
So I think there are several instances where there may be overlaps, right? Whoever you're working with on the third-party audit may also offer consulting services as part of their business. So, I think while you may be paying for two separate things, there may be instances where you can use one entity for everything. Auditors, they're their own separate thing. I don't know that many auditors coming into your facility would, help guide you in doing your validation or, ways to improve your food safety plan. They have a checklist that they're kind of going down to make sure you tick all those boxes. They will review your validation. So if there are, issues with validation, they might point you to other resources. But, I would say for the most part, you're not going to get a whole lot of consultation through that audit.
Great, thank you. And I guess, Jacob, since you kind of work in the third-party food safety world too, do you have anything to add?
Yeah, the third-party auditing body can't really consult. Like Dr. DiCaprio says, they have a checklist. And oftentimes that checklist has annexes that help you develop risk assessments or help guide you in some of these more difficult aspects of developing your food safety plan. So for Primus, for example, they have their checklist, and then behind that is all these explanations and annexes to help the producers comply with the items in the checklist. Yeah.
Great, thank you. Yeah, there's so many layers on these sometimes too. So, and what one resource can provide and what they can't is good to know. So we had another question come in saying, you spoke of RTE. We bake and package cereals and also roast raw snack mixes with no eggs. We fall in RTE category, correct? If we also bake small batches at a time, do we keep a full daily records of temperature time for each batch? And record keeping requirements seem a bit excessive unless I'm misunderstanding. So I don't know if you have any insight there.
Yeah, it sounds like, those are all low water activity products. So, if there was a potential for an environmental pathogen to impact those products, typically for a low water activity food, we would look at salmonella. I would say, if you're a smaller scale processor, I think the environmental monitoring, can be challenging. It's challenging for large scale processors as well. So I guess my question, I don't know if batch refers to kind of lot. So establishing your lots and how you're distinguishing one lot of product for another is really, really important. If you are, I don't know if your process is continuous or batch. If it's a batch process, then you would have to log that temperature and time for each batch. If it's a continuous process, you would, kind of be monitoring that temperature in real time and also monitoring belt speed through the oven to make sure that your product stays in the oven as long as it's supposed to. So I hear you on the records being challenging, but it's the way it is, unfortunately. I think maybe I missed some nuance in that question. If you're always welcome to send me an email too. A lot of times these questions are they vary so much based on exactly what you're doing, that it's easier to sit down and talk it through for an extended period.
Great, thank you. And I think that's kind of a good reminder just to check in with their extension folks or other resources for your specific process or product. So, and speaking of which, Stephanie, I was wondering, do you have any recommendations or resources on validation for folks in Washington State?
Definitely. So I'm going to put some links in the chat. So this just takes you to our food processing programs. And so we do product evaluations to help with your processing schedule. And then also, we have training programs. And then that'll also just put you in contact with our food processing specialist as well. So they'll have his contact information, and there's all sorts of resources that we can provide you with. So definitely, do take a look at the website. And if you need further assistance, you can reach out. Our food processing specialist is Dr. Gangel, and you can reach out to him if you need additional assistance. So these links will take you to that webpage.
Great, thank you.
Thank you.
So I think we're almost at time. So we'll start wrapping up. Erin, or Jacob, do you have any final comments that you'd like to add before we sign off?
Just wanted to thank Dr. DiCaprio. I always learn so much when I'm in one of these webinars. And then just if any of your controls involve materials or any kind of materials to control your processes, I would run it by your organic certification agency to make sure that it's approved for use in organic. Thanks, Erin.
Thanks, Jacob. And here's some resources from me. So we try our best to provide useful tools on our UC Food Safety website. So there's a couple of whole pages dedicated to validation. We have links to process authorities. Thank you, Stephanie, for sharing the Washington resources. We don't have the same, I would say, level of engagement on the process authority side here at UC Davis, but for those of you in California, you've probably worked with the UC Lab for Research on Home Food Preservation or California Department of Public Health. A lot of times, if there's more consultation needed rather than just a review of a process, those entities will send folks to my department. So again, feel free to reach out at any time if you have questions and need more guidance.
Great, thank you for the resources. And again, we'll be sending out a PDF of the slides, so you will have links to all of those. And as we mentioned, this is part of a series of a bigger project, and we were just curious about what other trainings folks would like to see moving forward. We're hoping to have some in-person trainings, fingers crossed, coming up later this year or next year. So if you want to just go and let us know what you'd like to see, and I'll give folks another minute or two and just end the poll. So it looks like there's a lot of folks interested in the Preventive Controls Qualified Individual training, as well as a number of others, Juice HACCP, basic good manufacturing practices. So thank you for your feedback, and we'll keep those in mind as we develop our future trainings. And then if you, we have one more webinar in this series coming up that'll be in April on cottage food laws for California and Washington. So keep an eye out for that. And if you've missed any of the past webinars or are curious about what else CCOF has in their video library, that's all on our YouTube channel. And finally, we have a couple of grant opportunities coming up through the CCOF Foundation. So if you have a young person in your life who is studying organic, we have our Future Organic Farmer Grant Fund that's open right now, and the application deadline is April 15th. So feel free to send them to our application page for more information. And then starting in April, we have our Brickmont Hardship Assistant Grants, which are specifically for organic producers. So if you know a organic producer business that has suffered loss over the past 6 months, also send them our way. And with that, thanks again for joining, and you'll have another opportunity to give us some feedback when you sign out of the webinar. There'll be a survey that'll pop up, so please feel free to click on that and give us a few additional suggestions. And thank you again to Erin and everyone else for joining us this morning. It's always great to have you all here and hear all of your insights and expertise. So have a good day, and we will see you in a month.